using the template that I showed in the first video, I center punched and drilled all these holes. Put these spacers on, but these spacers are high enough to clear these little unused standoffs that come in the bottom of all these cases. So I didn't feel the need to take these away. So now I'll proceed to mount the crystal oscillator, the buffer amplifier, and the boost converter. The only thing I have wired up right now is the LED, the crystal oscillator, and the input to this boost power supply. I have no connections to the output, which means no connections to the amplifier. I'm running this off of a USB power supply through one of these little USB voltmeter ammeters. I just want to see what it draws. And I don't know if you can see that. It says 0.49, 0.52. Now, this oscillator is supposed to draw up to a half an amp when it first starts, because it's going to bring this block up to temperature. It's now 5.5, but it's conceivable that this is drawing 50 milliamps. I believe this is all wired, RF and DC. I've got the output from the oscillator going through a 10 decibel attenuator to the RF input of the amplifier. I've got the output going to a BNC connector here in the front. I do not have it hooked to my frequency counter. Right now it's hooked to my QRP Labs GPS stabilized oscillator. 28 to 30 is generally what this counter reads high on a 10 megahertz signal. And right now it's bouncing between 28 and 29. This is adjustable. I can, if I had drilled a hole in the back, I could, there's a trimmer in there. I have never bothered to trim it. And I have to say, this has been powered up for years. I mean, continuously, except when there's a power failure. And it's been as stable as, it varies a couple of hertz. I've now connected the output of the frequency reference to the frequency counter and to the input of the scope, channel 2 of the scope. I'm going to turn it on. That is, I'm going to turn the reference on. It's drawing, according to this, about an amp. And you can see the frequency is 999, 850, 860, 870. It's drawing 1.2 amps. Now it could be that the amplifier is drawing current. The amplifier is now receiving a signal. It's 953, 957. One of the disadvantages of a oscillator like this is it takes some time to stabilize because of the heating. So it's not like a crystal controlled transmitter that you can just turn it on and go. Oh, by the way, I've got this set for 20 volts. So the amplifier is being supplied with, and it's getting hot. Maybe I should reduce that. And And you see what's happened? It's stabilized at 10 million, 30, 30, 31, 30. Current has come down to 3/4 of an amp. And you can see it's pretty well stabilized. I'm going to try to reduce this voltage to maybe, let's cut it in half and say 10 volts. So at 20 volts, I'm drawing 3/4 of an amp. And that current goes down drastically as I'm at 14 volts right now. And it's drawing 350 milliamps. This is still at 30, 31, 30. I can tell by looking at the oscilloscope, this thing is almost exactly 10 megahertz. I doubt that it's a hertz off, perhaps 0.3 of a hertz. However, I'm going to change this 10 decibel attenuator for perhaps a 15 or 16. Actually, the attenuator change didn't do much. I'm still overdriving the front end of the amplifier. I've reset the voltage to 10 volts. It's drawing 350 milliamps. And it seems to be very stable. I'll wrap this up tomorrow and publish it. Actually, it's been about 2 days or maybe 3 days that I haven't been in the shop. And so this thing's been running for 2 or 3 days since my last segment. Looking at the oscilloscope, you can see this is the output of the oscillator, and this is the output of my GPS stabilized QRP Labs oscillator. Both of them are 10 megahertz. Now, the difference is the time it takes for this peak to pass this peak and up next to that. So you see it's the difference in travel time between here and here. It takes almost 3 seconds, which would be 1/3 of a hertz. And this is exactly where I left it 2 or 3 days ago. And I might add, it's now drawing 350 milliamps. Adjusting this potentiometer allows me to fine-tune the crystal oscillator, fine-tune this oscillator, so it's 0.1 hertz. Well, stabilizing a little bit. It must not immediately respond to this potentiometer setting. See how it's wavering back and forth? So it's the output of the reference is very close to the output from the GPS stabilized clock. I tried to locate this little adjusting potentiometer knob, screw slot, as accurately as I could on this top cover. I intend to drill a hole through the cover and then place a plastic tube from the cover onto the adjusting screw and cut it off. I'll then cut the tube off flush with the top of the enclosure. This actually is an insulin syringe that I've removed the plunger and I took the needle off. The tube will serve then as a guide for an adjusting screwdriver. So this is what I meant by making an access port, so to speak. So once it's adjusted to length and cut off, it fits flush with the top of the enclosure and then extends down and touches the blue of the potentiometer. Now, if I was making this more seriously, I would have replaced this top-mounted adjustment with the potentiometer having a side-mount adjustment. And then it oriented the oscillator incrementally, probably 180 degrees, and accessed it with a longer tube through the front panel. That way, if I stack pieces of equipment up, and when I use this form factor, I tend to stack. I could have made it a tuning adjustment from the front and put a little hole in the front panel, super glued this end of the tube, it would extend back, and I make adjust something, noting what the hole's for. Put the case together. Now these are sheet metal screws. They're not machine screws, and this case has been assembled before. So I'll just back them up until that click comes, and that means I'm in the old threads. I'm not cutting new threads every time. So there we have our frequency reference. Now that little on-off jiggle, this little on-off jiggle, can tell when it's off. Didn't create any problem. Now it's off for 15 minutes or so. It will not be ready until a couple of minutes of warm-up. This is actually a square wave coming from the QRP Labs device. This is a distorted sine wave caused by the overloading of this amplifier that's in here. I have ordered from AliExpress an amplifier designed for power amplification. The amplifier that I have shown in this video has a real sensitive input. It's designed to be a pre-amplifier or receive amplifier. The AliExpress is designed to take about 1 milliwatt which is just about the output of the crystal oscillator, and deliver 2 watts of power. And it costs $5, I think. And it's smaller than the amplifier that's in here. I may replace the amplifier and see if I can get a better sine wave output. Anyway, there's our little reference. Some evening when I'm getting good reception on WWV, I'll show you how this can be zero heterodyned with WWV, which is not as accurate of a setting as comparing it with a known standard, but it's a pretty good reference.